Hi students, in this video I'll show you the basics and the introduction for hypothesis testing for a population mean when we do know the standard deviation of the population using the critical value method. Let's start by defining what a critical value is and how to use it. We start with a null hypothesis, and we assume this null hypothesis is true. Then we're given or we choose a significance level, which is the probability we're going to use to determine whether an event is unusual. Let's suppose we have a right tail test. The area for that right tail will be given by our significance level. The area is just the significance level. And we're going to call this region the critical region, which is the one that contains the unusual values. Then our C-score for any normal distribution is going to be called the critical value. It will denote the boundary between the values that are considered unusual in a critical region and the values that are not considered unusual. Then we're going to calculate a test statistic value, which is just the z-score of the sample mean. For this, to calculate the test statistic value, we need the sample mean, our mean established in the null hypothesis, the population standard deviation, and the sample size. Then, if our test statistic value falls in the critical region, we reject the null hypothesis. And when we reject our null hypothesis, given a significance level, we say that the result is statistically significant at that significance level, or we can also say that the null hypothesis is rejected at that significance level. Then, depending on what type of alternate hypothesis we have, we denote which type of hypothesis test we have. If we have a left tail test, our test statistic value has to be test for it to be less than or equal to our critical value. For this left tail test, our critical values are negative z-scores, and if that test statistic value is smaller, meaning that it falls in the critical region, we reject the null hypothesis. Similarly, when we have a right tail test, if our test statistic value is greater than our critical value and it falls on the critical region, we reject the null hypothesis. And for when we have two tail tests, we are going to divide that critical region area, meaning that our significance level the significance level value is going to be divided by 2, splitting that area into 2 parts. Then we find the z-scores, which will be 1 positive and 1 negative, and to test if our test statistic value falls on the critical region, we test our test statistic value to be greater than the right z-score or the right critical value, or our test statistic value to be smaller than our left z-score, which is our left critical value.